Hello friends, I am Anju Pakhale working as Assistant Professor in Physics at Government Institute of Forensic Science, Aurangabad. So today we are going to discuss about optical fibers. So what are optical fiber? An optical fiber is a transparent thin conductor as thin as human hair made up of glass or clear plastic designed to guide light waves along its path. So basically it is a conductor of light. So what does an optical fiber consist of? So optical fiber consists of a core at the center having refractive index n1. It is covered with another layer of glass or plastic which is also called as cladding, and then it is surrounded by a jacket. So what is a core? So core is made up of glass or plastic having a higher index of refraction than cladding, and core is the one who carries the signal. Cladding is the outer layer which is made up of glass or plastic with a lower index of refraction than the core. So if N1 is the refractive index of the core and N2 is that of cladding, though N1 will be greater than cladding. Then there is a buffer which surrounds the cladding which protects the fiber from the damage and moisture, and if one or more fibers are held together, then they are held together in a jacket. Then question arises, how does an optical fiber transmit light? So optical fiber transmits light with the help of total internal reflection. So as what you can see in the figure, there is an arrow and a bent pixel. So you must be remembering about your school days of reflection and refraction. So what is reflection? Just guess it. So as you can see in the diagram, a ray of light is traveling from air to water. So if ray of light is incident on the water surface and it is again reflected into the air, then that will be a reflection of light. And if the ray of light travels from air into water, then that will be refraction. So when a ray of light is incident on a same medium, it is reflected into the same medium, it is reflection. And when ray of light travels from one transparent medium to another transparent medium, then it is refracted. So what are the laws of reflection and refraction? So in case of reflection, angle of incidence I is always equal to angle of reflection R. And in case of reflection, so it follows Snell's law, which is n1 sine theta 1 equal to n2 sine theta 2. So N1 is the refractive index of the core, N2 is the refractive index of the cladding, theta 1 is the angle of incidence, and theta 2 is the angle of refraction. So as you can see in the diagram, again in case of refraction there are two cases. So if a ray of light is traveling from rarer to denser medium, say from air to water, then it will bend towards the normal. And if ray of light is traveling from denser to rarer, for example, a ray of light is traveling from water to air, it will bend away from the normal. Now what is total internal reflection? So let us consider a case. So in the figure, consider a ray of light which is traveling from say denser medium to rarer medium, say from glass to air. So what will happen? As angle of incidence increases, angle of refraction will increase. So at one stage, the angle of refraction becomes 90 degree. So the angle of incidence for which angle of refraction is 90 degree, that is known as critical angle. Now what will happen if you again increase the angle of incidence beyond critical angle? Let's see. So if you go on increasing the angle of incidence beyond critical angle, then the ray is no longer refracted. It will be reflected into the same medium, and this phenomenon is called as total internal reflection. So as you can see, there is a ray of light which is traveling from water to air. So if the ray of light is incident at an angle greater than critical angle, then the ray will be reflected into the water itself. Then let us consider this phenomenon in case of optical fiber. So optical fiber consists of an core. At the center, it is covered with another layer of glass which is cladding. So core having higher refractive index N1, cladding having lower refractive index N2. Theta 1 is the angle of incidence and theta 2 is the angle of refraction. So if this angle of incidence theta 1 is greater than critical angle, then ray of light will undergo, which is traveling from core to cladding, will undergo total internal reflection and it will come back again into the core. But if, what will happen if the angle of incidence theta 1 is less than critical angle, then the second diagram shows the ray will be refracted into the cladding or it will be lost, and that we don't want because optical fiber works on the phenomenon of total internal reflection, means light must travel within the core itself. Okay, then what is the critical angle in case of optical fiber? So recall the definition of optical fiber. Optical fiber consists of a core having refractive index N1, cladding having refractive index N2. So let us consider a ray of light which is traveling from core into the cladding. So if it is incident at an angle greater than critical angle. Now what is critical angle? So critical angle is the angle of incidence for which angle of refraction becomes 90 degree. So we have N1 sin theta 1 equal to N2 sin theta 2. So at critical angle, theta 1 will be equal to theta c and theta 2 will be equal to 90 degree. So N1 sin theta c equal to N2 sin 90 degree. Sin 90 degree is always 1. So N1 sin theta c equal to N2. So theta c will be equal to sin inverse of N2 upon N1. So in this way you can calculate the critical angle. And if the light is incident at an angle greater than critical angle, then it will be always reflected back into the core. Then how does light travels through the optical fiber? So as we have discussed, it travels by the phenomenon of total internal reflection. So again in optical fiber there is a core at the center having refractive index N1, cladding having refractive index N2 which is lighter than the core. So light is traveling from core which is denser to cladding which is rarer. So if the ray of light is incident at the core cladding boundary at an angle greater than critical angle, then the ray of light will travel back into the core and it will travel towards another end of the core. Now, as you know, the angle in reflection, the angle of incidence and angle of reflection are always equal. So, as angle of incidence and reflection are always equal, light will continue to rebound and propagate through the fiber. Through series of such total internal reflection, light emerges out of the optical fiber. Now let us discuss what is acceptance angle and numerical aperture. So acceptance angle is the maximum angle that a ray can have relative to the axis of the fiber and it propagates along the fiber. Numerically it is given by alpha is equal to sine inverse of square root of n1 square minus n2 square. And numerical aperture is defined as the sign of this acceptance angle. Means numerical aperture is nothing but a mathematical quantity or mathematical number which determines how much amount of light will be accepted within the fiber. So as there is a sign, there will be a cone also. So what happens actually in case of 3 dimension, all the light rays contained within a full angle 2 alpha are accepted and transmitted along the fiber. So this cone is known as acceptance cone. Actually this is an imaginary cone. There will be no cone outside the optical fiber. So it will be imaginary, but all the rays which are incident within this cone will be propagated along the core and at the output you will get the light. Thank you for watching my video. Please subscribe my video. Stay tuned for new video lectures. Thank